It's Rust in Production, a podcast about companies who use Rust to shape the future of infrastructure. I'm Matthias Endler from Corrode, and today we talk to Andrew Burkhart from 1Password about securing logins with Rust. Andrew, thanks so much for being a guest today. Can you say a few words about yourself and about 1Password?
Yeah, definitely. Thank you for having me. I'm Andrew Burkhart. I'm a senior Rust developer at 1Password. I work on the product foundations team, or in the org, I should say, on the frameworks team. So we specifically focus mostly on async Rust frameworks. I've been here about 3 years now, and working on data synchronization mostly, which has been pretty interesting as we grow. We spread kind of to other products that have come in. The password manager has kind of historically been our core business, and that's what people have known us for almost 20 years now. But over the last few years especially, we've grown a lot and acquired a few companies and so forth, and really spread ourselves across the security space, with various things from the password manager to developer tools and a lot of like enterprise password management features. And we have things like connect servers and so forth that, skim bridges that help with identity management, all these things. And then into the companies that we acquired, like Passage, which helps with passkeys, Collide, which does on-device health checking, Trellica, which handles, provisioning and some things like that. And so across all those various areas, Sync has been a really, really interesting use case to kind of combine all the various information we have in different ways. Yeah,
and by sync, you mean actually combining all of the information from like devices or user profiles, or what does that mean exactly?
Yeah, so the sort of summary, I guess, would probably be, federating or getting the data to be the same from clients to the Rust core to the server and all the way back around to any clients that are relevant. So that may be something as simple as, you and I are on the same 1Password account in the password manager, and I add an item that you now need. And so we sync that data across. But it can also be other things like, if you're in the enterprise space, just making sure that the data from one place talks to another and so forth, or that if there is relevant context from one area that is available in another area, things like that.
Yeah, I can totally relate to that, because one of the worst developer experiences is if data that you expect to be there isn't there or is in a sort of limbo. And
Yeah.
I think sync needs to be really reliable, and that's the core of the product. If that is not reliable, then, well, everything else is just a nice user experience, but it's not really, like, I would say user interface, but not a great user experience.
Yeah, definitely. And that's, it's created a lot of patterns, I guess you would say, that we hold pretty strongly to, like, sync here, conversations about this morning, actually. Sync here is always sort of a background task. So anything that you're doing, sync should essentially be a side effect of it. And it should happen asynchronously in the background. And, that way you kind of always assume that the data you have is current because sync has been happening in the background. And therefore you have the expectation that that data has already been brought locally to your device, which gives the feature developers a little bit of freedom because you don't have to go request things and wait for it and do this. I mean, there are cases where that has to happen, but in general, the vast majority of the data has already been brought locally and cached and so forth. So I can just act on that cache as though, I'm the only one using this data or something, which is convenient in a lot of cases.
It's sort of funny that you need async in order for something to be sync, but it does make sense if you think about it, because, well, it happens in the background, and a lot of things need to happen for it to look synchronous, but it's not easy.
Yeah, definitely. And you get into the nitty gritty details of like synchronous versus synchronized and so forth. And we definitely overload the word sync probably way too much.
So take us back a couple of years ago when you started. You said you're at 1Password for 3 years now, I guess. What was your background back then? Where do you come from? And then what was the state of Rust at 1Password when you started?
Yeah, so I had done mostly, my prior job had been a lot of Kotlin and Spring Boot, which, is kind of like, I guess, a framework for Kotlin doing server-side stuff. And I was doing a lot of that, like back-end web programming. I also worked on the front end a little bit with TypeScript and the Vue framework for UI. But I wasn't really like a front-end developer. It's referred to, I think, as like the BFF pattern, where like you have one server that manages a lot of different things. And then you have all these front ends that manage pieces of that, right? Like, for example, I worked on an app that did a lot of settings, like behind the scenes settings. And then we had a lot of other apps where actual end users would interact with it. And the one main server powered it all. But instead of muddying that server with, all these either, like you could use something like GraphQL, I suppose, but like instead of muddying it with all these APIs that supported vastly different use cases, we created these BFF servers where each front end has its own backend that then translates to the real sort of underlying backend. So I'd always done kind of that mid layer of development, and that was actually very helpful because it turns out, getting into the state of Rust at 1Password is that's kind of how Rust is used here. So each of our apps, obviously we have quite a few between iOS and Android and Mac and Windows and Linux and web and extension and all these different places. All of them are native clients. So they operate, the iOS app is in Swift and so forth. And then they are bundled with kind of like an embedded backend, which is a Rust, we call it the core. So the Rust core is inside of all of these, and that is doing as much of the business logic as we can to leave those native clients to just be display layer, essentially, or presentation layer. And then that communicates to the actual cloud server and so forth. And so Rust got picked up here. I don't actually know when it was, but my understanding is it was originally picked up for the Windows app that was being built. And over time, when we got from 1Password 7 to 1Password 8, I think it was, this again, it was slightly before me, but I think that was when it was like, okay, we need more cross-platform functionality because we're building so many features that were not originally just password management concerns, right? We're building all these different things and they need to work on all these platforms and we're implementing them over and over and over again. And so when they decided they wanted to create sort of the singular core that was going to power all the apps, they had already started to use Rust on Windows and it had worked really well. And so a lot of it just got ported over. And so when I got here, we were just in this kind of big growth phase back in 2022 and a ton of new people coming in. And so Rust was sort of proliferating very quickly as the core was building, all these developer features and these different things. And it was right about then we did a reorg of the development teams and created the team that I'm now on, which is the frameworks team, along with a few other teams that do, for example, like security-specific development or platform-specific development, like handling the nuances of Windows or Android or whatever it might be. And all of us kind of came together to design patterns and rules and so forth around Rust development to try to sort of wrangle all these different things that were happening. And that's kind of got us into the patterns that we have today, which have been really nice to, keep this giant core as maintainable as possible.
Nice. I want to get back to the patterns in a second, but before we do that, what did you use before Rust? Was it very platform dependent? Did you have this business logic in, for example, Kotlin and then Swift and so on?
Oh, yeah, exactly. So like I said, that was all before me, but my understanding is that everything was basically built natively, which gives you some benefits, right? There are pros and cons of that, but at the scale that we're at now, it's just not feasible to have that much code and have that many different implementations. And obviously, just when you're building a security app, multiple implementations is a problem, right? Anytime you have to do that, there is now the risk that one of these implementations is vulnerable in some way that the other isn't. And we're trying to compare, Swift code to Kotlin code to TypeScript to, Go or whatever and so forth, and make sure that these are all doing the exact same thing. But those languages may have different underlying models for async or memory management or whatever it is. And so it just wasn't feasible to continue on like that. And so the Rust core really helped us it just enabled features that weren't possible before.
In my idealized way to think about it, what I hope would happen is that once you merge in all of that code into one code base, into one Rust code base, that you see how different platforms or different languages solve these problems, or different developers solve the same problem, and some of them solve different edge cases. And then when you merge that together, you get a thing that is stronger than its parts. Did that happen?
Yeah, I think so. I think, and you get the opposite too, right? Where it's like, we'll get one component and it's like, what is this thing doing? It's like, oh, we ported that from this other version. Like, oh, that was the worst version. Why did we pick that one? And so you do see that. But yeah, I think in a lot of ways, you definitely get the benefit of that. And we see that having native clients. I mean, we've got developers who have done Swift and Mac development for, 20 years or whatever it might be. And so then they come at it and it's like, okay, hey, we need to build this feature. I need some help with the Rust side of it. And you see something and you're like, that's not at all how I would have thought to do it. And they're like, well, here's how we do it, in Macland. And you start to get interesting new ideas, I think, about how you can handle, how you can tackle various problems. So I think we get that just by nature of having all the different developers, but we definitely saw it in the growth of the Rust core and trying to pull things together, and now trying to add in some of the browser features that we had implemented natively in the browser. Now that we're trying to pull them into Rust and compile them into WASM, we're seeing some of those patterns again that we can learn from and improve throughout.
Was the Rust ecosystem prepared for what 1Password asked it to do, or were there any gaps in the crate ecosystem, for example?
I think there were probably some. I would say in general, yes. I think the ecosystem was growing so fast, and there were so many people building interesting things that I think it gave us a lot of freedom to innovate on top of those. I think there were small gaps, which is where you've seen some of the crates that we've put out. Gaps like, for example, having those native clients, there's no type safety across the FFI necessarily. If I'm writing Swift and then I send something into the FFI and then into the Rust core, I'm just hoping the types line up. So we created the type share crate, which is, it's not giving you necessarily complete type safety, but it is at least making sure that you're not writing the types on the client side. They are generated from your Rust code, so that if the Rust code changes, the client side types change. You're not having to manually keep those in sync. So I think that's been really helpful. And then there are other little things. Another one we released somewhat recently is called zeroizing alloc, which is like a wrapper around the global allocator that makes sure, if you're using this, whenever memory would normally be deallocated, which in that case, it's sort of just dropped, right? It's free for the system to use for other things. We don't want to just let that sit around in case the system doesn't need it and that memory sits there forever, right? We can't have that when you're dealing with sensitive data. So the zeroizing alloc crate will help to just flip those all back to zeros during that deallocation process. So there were little things like that obviously Rust as a language was ready for. There just hadn't been that use case necessarily. And so I think it created nice gaps for us to fill with some of those things.
Yeah, I came across this zeroizing alloc crate. Actually, before that, because the link was purple. So this is how I know. I'm surprised that no one else built such a crate before. Or did you look at some and didn't really like them?
I don't know how we came across that. And I wonder to some degree, like if you look at the crate, it's not particularly complex, right? It's a fairly straightforward implementation. And I've seen this in other cases where I think sometimes we look at a problem and we go, oh, it's so simple. Like I don't need to make a crate to deal with this problem. It's maybe a common problem, but it's like, I'll just throw this together. And maybe people don't want the dependency or something like that. I'll just kind of hand roll it very similarly or something along those lines. I think sometimes that happens, right? And people are obviously wary sometimes of dependencies, especially ones that do smaller things, right? We saw, I think, in the TypeScript NPM world, there was like the left pad incident, right? Where like all this thing is doing is handling this left padding. And it's so simple, but then when it's gone, now we have a big problem, And so that could be the reason that some of those things just don't get created. It may not be, I doubt we were the first people to think of it. It's probably something someone else had solved before. They maybe just didn't make a crate for it or something like that. Or maybe there is one out there and I just haven't seen.
What is the policy around creating crates at 1Password?
This has been an interesting thing that I've seen here, right? Is because 1Password, the password manager concept, is 20 years old, right? And conceptually, a lot of it is similar to what it was then. And then the Rust app itself, now is, 5, 6, 7 years old. I don't know exactly how old, but it's been around a while. You have these things that have grown so much. And for the most part, creating new crates internally, it's just a matter of, code architecture. Does it make sense? Is it a necessary separation, right? A lot of problems you deal with anywhere. Making crates public is sometimes tricky because one, you have to figure out, does this make sense to make public, right? Like zeroizing alloc, we probably could have left that internal, but we figured it might help some people. And it's not like a, private, secret thing that 1Password does. I think a lot of people know that, we have to deal with memory this way. So you have some of those initial concerns about whether or not we should make this public. And then it's untangling it from everything else you've built over the last few years, right? And, there are things like our, clipboard manager, it's called our board, that's made public, and you got to go, okay, well, we had all these, 1Password specific assumptions that may have been baked in. So now we have to pull those out and make this just a dependency as though it were a third party dependency to us as well, and so a lot of it is just small bits of process of untangling things. But as far as deciding to make it public, that's pretty case specific, I guess, or situation specific. And I think we've been trying to get more and more out there. We released, for example, the passkey RS crate, which I think is only valuable to other password managers. Like, I don't know if there's anybody, because it really just validates, like, does verification of passkeys. And so I don't know that anyone else would ever need it. But, we released it because, one, it might help them. And we really want to see passkeys get adopted in more places, even if that's, in a competing app. We want to make sure that that's available and so forth. And it's also just interesting, Rust that people might be able to learn from and so forth. So, yeah, it definitely depends on the situation, but it's a bit of a process either way.
Maybe one of the listeners checks out that crate and builds a thing that we both haven't anticipated. It happens more often than I expect. And the other thing is, open sourcing software, whether it's Rust or not, is a huge lift for every company. Because what a lot of people forget is everything other than the code: versioning, documentation, testing, CI, communication, and so on. And also, to some extent, exposing how you build things at a certain company. And also, a lot of developers are afraid to share how they write code. Did you ever get any external contributions to make it worth it?
Yeah, I mean, especially with TypeShare. I'm trying to think of what language it was. I want to say Scala or something like that. Like we don't use Scala, and so we never built, a TypeShare integration with Scala, but someone from the community did. So now I want to say it's Scala. Now there is, the capability to convert your Rust types into Scala and so forth. And I think those are nice. I don't know that we've ever really open sourced anything with the hope that people would build features that we need. We generally are trying to do it sort of the other way around, make sure that our work is helping people where we can. Like you said, it can be tricky, especially just from an operational standpoint, right? I think I saw we have 150,000 businesses that use 1Password or something like that, or more than that.
Wow.
So when you have that number of people, the number of needs is pretty high, right? We have a lot of, this company needs this thing and this company needs this thing and so forth. And if you open source something, you lose the ability to make breaking changes quickly, right? You don't want to, I guess you technically could, but that's not a very good open source project, right? If you're just breaking it all the time. So that's one of the harder parts is, when you're making that decision, is this something we can open source? And can we give, like you said, versioning, can we give any kind of guarantee that if we make version 1 and version 1 is stable and safe and it's good, that's fine. But now if we need to make version 2 a breaking change because we need it for something we're trying to build, well, now version 1 kind of becomes unsupported. So if version 2 doesn't work for what you're trying to do, well, now what if there's a security vulnerability with version 1? Now you've created these two branches that should be maintained by someone. And if that happens a second time and a third time, you just create this web of challenges. So, it would be great if we could open source everything, and let everyone see all that. And I'm sure there are paths to that. It just doesn't, it's not very easy. Like you said, it's very challenging. It's not as simple as well, just make it public. You've got to do a lot of management to make that work. And, as things ebb and flow, that can be really hard to keep up with, responsibly and reliably.
Yeah. And even if you didn't open source it, and even if you just used a crate across different teams, that is still a challenge. Do you have a monorepo? What does the structure look like right now?
Yeah, so it is a monorepo. We have various repos for services and things like that, but the Rust core itself and all of the client apps built on it is a monorepo. which gives us some benefits from, sort of a build and release avenue, right? Where everything, you don't have to bring in other, repos and so forth to keep everything up to date. It's all in one place. But like you said, that means that, merge conflicts can be a problem and all these different things that are reliant on what you're working on. And that's tricky, especially from, a team sitting where we do, kind of at the very bottom of the whole stack. When we make a change, there tends to be a very significant ripple effect that, and you get into challenges like, how do we manage that, right? Does our team, if you have code that depends on that, do we just tell you, hey, we're going to break this and you need to be ready to work with us to do the new thing? Or do we fix it for you? And so forth. And there can be a lot of communication that needs to occur as you grow. And you talk about like the mythical man month, concept, right? Of like throwing 2 more people onto a project does not give you 2 more people's worth of time, right? You have extra communication. There's all these new channels that have been created between those people and the other people and so forth. And it will test your processes and your org structure and your code architecture, at every turn. And so when you get to hundreds of developers working on sometimes completely different, things, right? They're not even password management concepts. They are, they may be related to secrets, right? Like the SSH agent that 1Password has. Well, that's related to some amount of secret, but it is not at all related, to profiles or settings in the password manager, things like that. So you can get into, challenging situations where you're trying to coordinate underlying frameworks across completely different, feature teams. And yeah, that's problematic at times, and it definitely can slow things down, but it also becomes a strength when you're learning from those things.
Yeah, let's talk scale, because people like numbers. Can you share some of the, let's say, I would say more interesting numbers about the code size and the number of people working with Rust and crates maintained and so on?
Yeah, so I think I just looked the other day and we were at like 500,000 or 600,000 lines of Rust in the core across like 600-ish crates. I think we're just shy of 600 crates internal plus dependencies. So it's a pretty big code base, right? And like I said, that core makes up as much of the business logic as we can get it to. So I don't know the exact spread of all of it because, when you're implementing a feature, you have to also implement it in the native clients, right? So some amount, every feature is going to have some Swift and some Kotlin and TypeScript and all these different things. So I would say,
you know how frustrating data pipelines can get, right? I hear from customers all the time about their teams cobbling together different tools, watching costs skyrocket while their teams get increasingly frustrated. And that's where Infineon comes in. Some of you might remember that we had Deb from Infineon on the show a while back, and their platform Fluvio is built entirely in Rust, which immediately caught my attention. What stood out to me is how they've simplified everything into a single composable system. Their stateful data flow operators let you transform data right in the stream and build daisy-chained stateful services, which means no more jumping between different tools. And the performance is no joke. We're talking hundreds of megabytes of throughput on commodity hardware with just milliseconds of latency. It only uses about 50 megabytes of RAM when idle. And the developer experience is great as well. They have a clean API, an intuitive CLI, and speaking from experience, Deb is always super responsive whenever you have questions. That kind of support makes all the difference. If you're building anything with real-time data needs, may it be trading platforms, fraud detection, or gaming analytics, I think you'll want to check this out. And because you listen to this podcast, you can get an exclusive discount right now during our current season. Just head to infineon.com/rustinprod and mention our show when you book your demo. That's infineon.com/rustinprod.
And then you got server-side stuff, which not all of our server-side stuff is in Rust. There's a lot of Go on the server side. So I would say probably 50% of everything new that we write is in Rust, but it's definitely spread across all those other things. Writing an end-to-end feature will involve Go and Rust and Swift and Kotlin and TypeScript and possibly Go on the CLI side and so forth. So there's quite a bit that goes into that. But there's probably, I think we have a couple hundred developers now working across all the different products that 1Password and, Collide and Passage and Trellica and so forth have. But we probably have, I don't know, I'd say 100 people that work pretty heavily in Rust or maybe 50% or more in Rust, something like that. But that's definitely a bit of a guess.
Awesome. Which FFI bridge works the least well for you right now? Like, what gives you the most headaches at the moment?
It depends. I think as far as the actual FFI goes, the most challenging ones are probably, I guess Android can be a little bit tricky sometimes. Especially just Android, the ecosystem's a little bit different. We were built originally as a Mac OS app. And so I think there's still a little bit of that sort of, Apple product DNA built in, which, we've tried to spread to all these different platforms and make everything work equally well. But I'm sure there's still a little bit of that in there. And then the WASM boundaries can be tough. I didn't know anything about WASM until about a year ago, right? I don't think I'd ever really touched it at all. I'd heard of it and knew nothing about it. And then you find out little things like I think there's like no built-in clock in WASM or something like that. So you're like faking all these time-based things that you used to do. And so that can be a little bit tough when you have concepts baked into how the native clients communicate across the FFI that just don't work in WASM. And we end up with a lot of abstractions. Like we have, there's send and sync traits in Rust, but we have a maybe send and maybe sync trait that handles, for people translating between, is this going to be single threaded or multi-threaded and so forth. And so the WASM boundaries are probably the toughest, to be honest.
Okay. Yeah. The maybe send and maybe sync sounds interesting. Wouldn't that be a question mark send and question mark sync?
I think it could be. Yeah, I think what we have, so the way we've broken this out, right, is because we want, code to be reusable across platforms, right? But it may not necessarily work quite the same. Let's say for passkeys, or autofill, like that happens completely differently on iOS than it does on Android, than it does on, Windows or wherever. And so there's all these different implementations, but you want to do the same process. It's just that all the underlying calls, there may be syscalls or things like that, where you're reaching back out into the OS, they work different. Or, some of them you have to do it in the moment. Some of them you have to seed some operation at unlock, or whatever. And so what we try to do is we have these, we have FFIs by platform. And then we have like an app level where you could have multiple platforms that use the same app level crate. But then what that does is that reaches out into services. And the service level is where all of your actual functionality comes in. For example, Sync. There is a service that handles Sync, and there's, a different service that handles autofill and so forth. And then those reach out into underlying implementations of things. And so what we do is we try and make a trait that is like, okay, here is, let's say, I don't know, passkeys or something like that. And then underneath that, it's like, all right, get the passkeys. But then below that, it's like, well, what do we need to get? Which data are we getting? When are we getting this? How is it being provided? Do we need to get anything from, the enclave or the operating system or whatever it is? And those get implemented by platform. And that gives us a little bit of flexibility into how we build up things. But what that means is if I'm doing something that is generally, we have built this and have used it, let's say 4 or 5 years now, completely async, right? And we've been using, we spin up a ton of threads to do this thing or whatever, or it's got to be on a background task or something like that. Well, now maybe that doesn't work in WASM. And so I think maybe send and maybe sync have been our easy traits to kind of layer in to be like, all right, put this on there to make sure, we can sort of keep these things moving forward. And then that becomes a big challenge throughout everything, right? When you've got, 500,000 lines of Rust and now you're trying to build in WASM, that's a lot different than we're starting from scratch and building in WASM support, right? We could have done things probably a lot differently, but there are hundreds of features across, a dozen products or whatever that are trying to use this stuff, and going back and refactoring them maybe just doesn't add up right now, and we don't have time for that. And so there are probably other ways we could use those effects or whatever they call them to better use. I think these are probably our temporary solutions.
But I fully get it, because at some point you also need to ship things, and this seems like an escape hatch that kind of was a pragmatic approach to solving this problem. What a lot of people forget is that these are apps that eventually need releases to change, or if they have breaking changes, then it's not that easy because they might be used in other parts of the application. So the other thing I wondered was, Is there a guideline for keeping the core synchronous Rust? How deep does the async part go, and at what point do you stop using async and do you start having your own little, say, domain which is sync? Is there such a differentiation, or would you say that doesn't make any sense at your scale or for the project you do?
It might make sense in some places. I don't know that we really do it much, though. It's definitely pretty async down to the root of things. I mean, the way our requests from the client into the core work is, you make this request over the FFI, which is sort of inherently async, right? Because that's not an API where you're waiting, it's not baked into like the HTTP protocol where you're going to get a response and
right.
blah, blah, blah. So you sort of send this request into the core over the FFI. And then what the core does is that FFI holds on to a sender and it hands off that request to a thread that is watching the receiver. And that dispatches invocations, these requests that do the work and handle the type process and blah, 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 and then come back. And the way that we handle that is the front end sends in a callback that once the request is done processing, that invocation dispatch loop executes the callback with the resulting data as an input to that callback. So that way the client side handles sort of a registry of here are all the requests that I have made and sort of an identifier. So when that callback gets executed, I can put it into my local cache or store or plug it into this React component or whatever it might be. But the whole process is sort of inherently async. It is baked into, everything from client side all the way down to the database and back. So I'm sure there are some things where it's like, hey, we need to do multiple things and they need to be synchronous in order, but they're a bit of like a bubble that's still within an async, flow end to end.
The callback mechanism that you describe sounds a lot like the Waker in Tokyo, but just on a higher level, I would assume, like on a data level somehow.
Exactly. Yeah, it is kind of like that where it is sort of, I guess it's like building in our own hand-rolled Waker in some way of like the client technically sends off this request and it's done in theory, right? Or technologically, it is done. But it is set up this function, that is somewhere in memory and it has handed us off where this thing is. So then when we go call that code with this data, it is now kicking off a new thing. It just so happens that we have encode tied those two pieces together, right? So it's sort of like the mechanism of a Waker, except that we're not actually, pulling it or anything like that. It is inherently async to when that thing gets called back.
Did you have to use any unsafe code to pull it off?
I'm sure in the FFI there's some, just the nature of how FFI works. I'm sure the calls across the actual FFI are wrapped in unsafe. And then I think there's probably some, we talked about zeroizing alloc. I'm sure there's some amount of wrapping there to ensure that bytes are flipped to zeros, in things that were not being handled by the Rust allocator. But in general, the process is fairly safe, right? You make the call over the FFI. And because that is holding this object with the sender, once you send that all across, that's fine. Everything there can be done safely. And then executing the actual callback probably technically has to be wrapped in unsafe, I would guess, because you are sort of triggering just a memory location. But a lot of that is based on, guarantees that we can make in both sides of the equation.
So you mentioned 600 crates. And when I heard that number, I was, awestruck.
Yeah.
How do you not drown in dependency hell? How do you keep all of these crates up to date?
Yeah. I think you're assuming we aren't drowning in that. No, it's it's not too bad. I mean, so part of it is automation, right? Making sure that we're running things to ensure, like we have dependency monitoring for vulnerabilities and stuff like that to keep all that stuff up to date and make sure that we're not passing pipelines that have vulnerable dependencies. And also if we have a dependency that's become vulnerable, we're updating it quickly and so forth. But beyond that, it can be tricky, to manage all those dependencies. A lot of it just comes with the architecture of like, let's make sure, we have directories, right? So we have, let's say, a data directory. And this data directory, okay, you are allowed to import anything else that's in the data directory or any, third-party dependency that's safe, but you can't import anything from services or apps or so forth, right? And we create a bit of a inherent hierarchy to these things. And so a lot of it is just making sure that we have clearly defined, like, app crates cannot, or app crates can really import anything that they want except the FFI. And app crates should only be imported by the FFI. No one else should ever import an app crate. So there's our first, level. And then we go to services. It's like, all right, services can be imported by each other or app crates, but nobody else. And now, data can do this, right? And you create a little bit of these rules, and then you end up with a ton of things that fall outside of that. They may be crates that define types or a server client or all these different things. And that's where you get into the difficult parts of, like, well, if we have a server client, who's allowed to use that? Can anyone call that from anywhere? Or should that ever talk to the data, crates? Or should we keep those separate inherently? What about types? What if we have a type that is this way on the server and it is also that way in the database? Well, do we want to duplicate that to let those, like, to let drift be okay? So that way we're not, modifying both all the time or one all the time. So you definitely get into challenges that come with having that many crates. And there's probably more automation that wants to happen, but there's definitely, the short answer, I guess, is there's a lot of human process that comes into, we have different teams that own different concepts. They don't own necessarily specific bits of code. They may, but in general, they own concepts. And because you're owning that concept, we have automation, that will say, okay, these bits of code definitely touch that concept. Or just a lot of people going, okay, this should probably be reviewed by such and such team or so forth. And just making sure that we keep everything as clean as possible. And that we are, when we do code review, we're looking at it to go, does this order of imports make sense? And we'll have things where it's like, oh, they implemented this on some model, but it doesn't need to be there. It was only being consumed in one place. So let's just inline all of that. Let's get rid of that crate, that whole model concept. Let's just inline it right where it was. And then we may find out in the future, oh, well, now somewhere else wants to use it. Okay, let's pull it back out and put it back into the model, and we'll do that, And that's okay. We want to avoid the, like, well, we might need it in the future, because that's when crates really become a problem. We put it in this new crate because we might need it somewhere else. Let's not do that. Let's just inline it until we know we need it somewhere else, and then we'll deal with pulling it out. And that's really the only way that, you kind of bake in avoidance of crates just proliferating everywhere.
It sounds like you're treating crates like cattle. I wonder how much the Rust ecosystem helps you with that, and how much of that is still manual. Because there are tools like cargo deny, for example. I don't know. Do you have any tools that you like outside of, say, Clippy, that you prefer?
Yeah, a lot of Clippy here. Definitely cargo deny as well. Make sure that, again, that, if it's an FFI crate, you should only be importing certain things, or if it's an app, you shouldn't be importing certain things, or so forth. There's, again, it probably wants more automation than we have. A lot of it is just the code architecture, right? If we make sure that the data layer is self-contained, and then we make sure FFI to app to service is a self-contained flow, well, everything else then becomes domain specific, right? We're not creating global things beyond that, wherever we can avoid it at least. So that way, if your team, let's say, works on autofill, you get to use the data layer in prescribed ways, and then you import all your stuff into a service, which goes into an app, which goes into the FFI. Anything in between there, that's up to you. If you create a circular dependency or whatever, that's your problem. Or if you create a bad architecture between these things, well, you have to own that, right? You've got to maintain that. And so you're going to find the problems with that and generally fix it yourself. And so a lot of it is just that architecture of, like, keep the top layer contained, keep the bottom layer contained, and then everything in the middle is feature specific or domain specific. So that way those bounded domains are dealing with themselves. And there's a couple other things that have this, like, we have a foundation directory, which deals with OS specific calls. Anything that's Windows specific has its own area and so forth. So there are a few other things we do like that, where it's like, okay, that is maintained by this platform advancement team. And if you need changes there, you work with them to make those changes, but you are just consuming those things. And any, interweaving of crates that you do within your bounded domain needs to happen within the, box you were provided. But it definitely does rely on a little bit of that automation, like you said, of, like, cargo deny and Clippy and so forth, to ensure that we are cleaning that up where we can, but it's definitely a manual process a lot of times.
I'm not sure if it's true, but I heard that 1Password uses Nix for their development environment. Can you say a few words about that?
Yeah, so we definitely have a lot of a Nix usage. So it powers our on the core side at least, it powers a lot of our build processes and stuff like that. And then we use it to manage our tool chains on the core side as well. And that has been really, really nice because there is so much, tool chain stuff that you need when you're working across all these platforms. You might need all of these Linux specific tools and you need these Mac specific tools and all these things that make Android Studio work. And there's all these different things that come together as well as, internal tools, right? We have the 1Password CLI, which we use for things, and the TypeShare tool, which is a CLI tool that is used for things. And so whenever we make updates to TypeShare, that needs to become part of developers' tool chains. And so we use Nix to manage all of that. And that way, whenever there's an update, if I pull main and that Nix flake has changed on main, well, my toolchain just gets updated. And I don't know the difference. I have to wait a few seconds for it to pull everything in, build the toolchain. But from that point, I don't care. And there's the durenv tool, which basically sets up that directory to automatically use the Nix flake as your toolchain for that directory. So I don't have to worry about version management. I don't have to worry about, did I run the install script too long ago and somebody added something to it since then? That's not my problem. Nix just handles all of that. And it's been really amazing. I mean, there's a bit of knowledge, Nix specific knowledge, flakes in the language and all these different things can require a little bit of playing with to really understand what's happening. But it's been really powerful and it's helped. We have a concept here, which I know some other companies have as well. We call them guilds of like cross team interest in a topic. So like there is a Rust guild, right? And we have all the developers on different teams. Like my team has, let's say, 4 Rust developers and then some other developers. But then the autofill team has a couple Rust developers and this team and so forth. And we don't maybe collaborate all that directly. But now in the Rust guild, we can just talk Rust. We don't worry about, interactions with other things. We just talk about how do we want to write Rust? Here's an interesting article about Rust, so forth. And we have one of those for Nix as well. So, the build and release people are in there and some of the people from my team who are all just kind of Nix fans are in there and so forth. And that helps us to make sure that, someone who maybe owns the tool chain is working on something, like, hey, I couldn't figure out how to do this. Well, now there's a bunch of other people who just work on this in their spare time or, have their home set up in Nix and so forth. And like, oh, I've done that here. And we can sort of augment the knowledge on various teams and really help to skill people up. Like the Rust Guild, we run a Rust study group that has, I think we had like 160 people in it or something like that the last time I looked. And so it's people, going through the book together and learning from some of the experts that work here in Rust and then working on projects together and all these different things. And it helps us to really kind of like raise the floor of skills in all these different domains, including Nix.
About the external dependencies, so any of the popular crates, are there things that you use from the ecosystem that you kind of wanted to mention? It could be anything, really.
Yeah, I mean, so obviously, like I said, we use Tokio a lot, and we use the whole Tokio ecosystem, right? We're using Tokio itself for, channels and all these different things. We use Axum for various services and so forth. Tower, the Tower middleware is really, really helpful because it allows us to share things. If we have one, again, feature that's totally independent from some other feature, but if they create a middleware that handles, this handles authentication. Great. Well, now this one can use it too because we auth the same way. And so it allows a lot of sharing there. Tracing is really critical. Obviously, again, having so many features and so many layers, using tracing gives us a lot of visibility into, did I make something that just slowed everything down? Or where is my slowdown occurring, and so forth. So that's great. Saturday is obviously pretty critical as well, right? We have to do a lot of serializing and deserializing, coming in from the server and so forth. So that's really helpful. And then some of our internal crates, right? Like I mentioned, like TypeShare, PasskeyRS, and so forth. The only other ones that I know of that come up a lot are like Rust QLite is important for SQLite interaction. That makes things a lot easier. And then testing things, right? Like mock all is good. Cool asserts We also have some developers here who have public crates that we use that are nice. Like one of our developers, I think, works on Neon, which handles like Node.js bindings for the Electron apps. Nathan West, who's here, made Nom Supreme, which is a Nom helper library, which is really cool. I really like Nom Supreme, and so forth. And so there's a lot of really cool things. One of my teammates, Ivan, also has a project called Crane, which helps with Nix projects. And I don't think we actually are using Crane here, but it's funny because we'll come across open source projects. We'll talk to other teams. We're talking to the team that built the Z editor when we were at RustConf, and so we opened up some communication with them, trying to help kind of beta test some stuff that they were working on, and they were using Crane to build Z. And so I was like, oh, that's funny. That's something that one of the people here made. And so it's kind of neat seeing the ecosystem come together. But yeah.
Totally. That's always surprising. The code sharing that happens between different companies using Rust, that's always very surprising. And by the way, if someone wants to listen to the episode we've said, it's been a couple episodes before. These guys are doing amazing work. We can't talk about all of the crates, but one thing specifically that I wanted to ask you about was the tracing ecosystem of crates. Specifically, if you use tracing in combination with the log crate, or if you use tracing for tracing plus logging, which is a very popular usage of that crate.
Yeah, so that is actually something I think that is coming about now. I mean, we've used tracing primarily for tracing, right? For sort of internal performance telemetry a lot, and we have a lot going on there. But one of the other things now is, especially, in our cloud infrastructure, trying to make sure that, we have we have services in various languages, especially now, that all these other companies are coming into the fray. There's, Ruby and, .NET, I think, and all these other things. And so we want to make sure that our observability is not hindered by that. So we have some, intermediate things that are handling, let's say, logging output and making sure that it is normalized so that we can handle observing, cross service, the whole ecosystem, right? And so that's something that I think we're actually doing now, is using tracing, a tracing subscriber to make sure that our log output is, meets the standard, essentially, so that any given Rust app can output their logs in the right format and make sure that they're consumable by these other services.
Are there any things that you specifically like about tracing or you dislike about tracing right now?
I don't know. I didn't work on the implementation of it too much, so I would say I don't have a lot that I dislike about it. It's really nice to be able to just jump on to, have some function and go, I'll just add the tracing macro to this, right? And now I'm getting data about this, and I can instrument these things very quickly and easily, and it adds in there, and I'm seeing, everything that I want. It's been a huge help to be able to go, one of the things we were looking at was like, when we do these invocations, right, they are sort of inherently async, but you may have invocations that are performance heavy, right? Something that has to, like, let's say, iterate through a giant list, and it just has to happen that way. So we have a blocking thread pool. Tokio gives you can do a blocking task, right, on this blocking thread pool. But you also have async tasks, and async tasks tend to be more, cooperative in a lot of cases. And so we got down to the point where it was like, we have hundreds of these invocations. Well, how do we know which ones should be blocking and should be async, right? If it's gotten a wait, it needs to be async. But out of the 100 that maybe don't have an await, which ones are better served on which thread pool? And so we can use tracing and just go through and just literally flip it from blocking to async and, do the little minor, syntax conversions we need to do, and just do A/B, one to the other, and go, okay, here was this one, here was this one. Oh, it's faster that. Let's put it over there, And it makes it really nice to be able to just kind of jump through all these things. I did that, I think it was, like 2 years ago now, and just ran through every invocation as it was, and then flipped them all to the other one and see which one's faster, and had an MR with just everything. Here's what came up faster with tracing, and here's all my results. So tracing is incredible.
That's a really nice use case for tracing. The other thing is Tokio Console, which is similar. I don't know if you've heard about it, but it shows you the state of Tokio and the futures that executed and how long they take. Did you hear about that?
Yeah, Tokio Console is pretty awesome as well. We have, I think Ivan, actually, the one that I mentioned who works on Crane, I think he also is one of the maintainers of Tokio. But Ivan is has helped me learn a lot. Like I said, I had no Rust background at all when I got here, and Ivan is a Rust expert. We have a few others as well. Like I mentioned, Nathan is absolutely incredible, just the things that they know when it comes to Rust. But the last 3 years, I feel like I've learned more from Ivan in the last 3 years than I learned in the prior, 7 or 8 combined, everything that I did. But yeah, showing me, when you get through and you got the client app running and it makes this request and we're dispatching, this one task, and then that may kick off other tasks, and the database access is all asynchronous, and so there's a queue of these requests, and then there's events that get triggered off of that, which may trigger other async tasks, and so all this stuff is going on, and looking at all of this stuff in the console is a huge help to get visibility, like what's really happening, right? I see a log message just starting sync, and then I see a log message that says sync completed. But inside of that, there was so many tasks that spun up, and some were slow and some were fast and so forth. And so, yeah, like you said, Tokyo Console is really great for understanding the futures that happened. We use tracing, I think, more for like function calls, right? Like in our case, at least, like we called this function, it is instrumented. I see this function took 10 seconds. And inside of that, this one took, well, I guess 10 would be a long time. Let's say it took 100 milliseconds. And inside of that, here are 3 others that took 10 milliseconds each, right? And I get that visibility. But seeing the futures that kicked off and how long those took does really give you another level of visibility into what's really happening under the hood.
Right. If I understand correctly, you don't trace every future, but you kind of group them into logical units, things that make sense to be executed together, just to get some insights.
Yeah, and that's another thing, that's really great about the way that the Tokyo Tracing crate is set up, is that you have like the spans, right? And you can create spans and enter spans and all these different things. And so we use those pretty heavily. There are probably scenarios or code paths where individual futures are traced. But in general, a lot of times it'll just be when we're going to some block of code, how long is this taking, right? What is happening here? And so it's not always every single future. It is specifically what we're trying to instrument, right? And so having the console as well is very helpful. But those spans make it nice to have logical grouping, like you said, of different concepts. And so I can see within the span, how long is the whole span taking, and then how long are individual blocks of that span taking, whether it's multiple futures or one. I may or may not care, how long the individual futures take, right? Let's say I have some future that does some unit of work, and that unit of work has to happen, and there's no other way to do it. Maybe I don't necessarily care how long those futures take, but I do care how long this block takes, and that may help me, determine, this is a vec, and it doesn't need to be a vec. Maybe now we can order it, and it, with the data sets we have, it makes more sense to spend the upfront time hashing this or making it a B tree set or something like that and ordering it all, so that, most often what we're acting on is we're inserting somewhere. Okay, this gives us that speed up on insert, and it's often worth, the time to sort it or something. So yeah, the spans are really nice.
Well, some people might listen to this and say, I will never get to this level of proficiency. And maybe they are curious what it feels like on a day-to-day to work together with maybe 100 other Rust developers on the same code base. What are some of the patterns that you see evolve over time? What is the complexity like? Is it a thing that people can teach themselves? Are there any guidelines? What are some things that you would say evolved since you started working with Rust that you would say you should definitely follow this, and these are the best practices that we see at 1Password?
Yeah, so I would say first and foremost, when I got here, when they interviewed me, they tried to show me some Rust code because I had never done it at that point. They showed me some Rust code, and it was essentially a number-aware sort. So making sure that, 1Password, shows up in the right order in this list or something like that, right? And I could not get through it at the time. Like I was generally following, like it's trying to do this, but it was using these chunks, and I didn't really know what that was. And then it did a little bit of memory stuff, and I had never touched memory coming from Kotlin TypeScript, so I had no clue what was going on. And luckily they hired me anyway. I don't know why, but they did. And so, in the last 3 years is everything that I have learned when it comes to Rust, right? That's the only time I've ever seen it. And so it's definitely something you can pick up. I have not done it alone, right? I have had multiple teachers who are absolutely incredible when it comes to Rust. And like I mentioned, we had that Rust study group, which is something that I took part in the first iteration when my coworkers Tanner had set it up. And then it had been so massively helpful to me that I ended up taking it over and running the second iteration of it. And now, we've grown this into this whole Rust guild. So all that to say, anytime you can learn from other people, it will be massively helpful. I think especially in Rust, because you may be coming from languages where the concepts just don't exist, right? And you're trying to learn all these brand new things. So that's a huge help. You can learn it on your own. There are a lot of good resources out there now. One of the things that's been really incredible in the Rust community is there's a lot of the books that are amazing books in Rust that are just free, right? Like the Rust Atomics and Locks book from Mara is free. You can get it on the internet, also buy it if you can. But there's so many of these things. The Rust book itself is really great. One of the hardest things to get from, zero to productive, I found, actually, I spoke at RustConf a bit about this past year. What we found teaching people is the issue is not learning the Rust syntax. It tends to be that good Rust requires a bit of engineering knowledge. And that's not maybe engineering knowledge that the book is covering, right? And you and I talked about this a little bit, right? Like, how do I know when I make a new crate? Well, the Rust book it's not going to tell you that. That's not really a Rust problem, right? That's your code base problem. It's an engineering problem. It tends to expose your lack of knowledge in other areas, which again, I also have no computer science background. I was a construction worker before, and I worked at a drugstore before I became a developer, so I had no idea about binary trees and sorting. I still really don't, to be honest, but Rust has a way of bringing those things out in you, which is hard at first, but it also helps you to shore them up because you see where your gaps are. And there is so much information out there that you can learn from. But it does take time, and not everybody has time. So that can be a bit difficult. But anyway, that's a long way to say you can learn on your own, but learn from others wherever you can. Look at code, try and understand it. And then getting into patterns, a lot of it has been thinking about two things, I think, heavily. Why are you abstracting something? Because abstractions are really big in Rust, right? Like I said, we use Rust QLite, but we wrap every transaction so that we add some counter that we want to follow in debug mode. And then we have to wrap, maybe the call to save to increment that counter, right? To insert a row to increment that counter. So you end up with abstractions on abstractions on abstractions. And if you don't know what you're looking at, those are even harder to follow. So making sure that your abstractions make sense, and if they have to be complicated for any reason, document them really well. That's, critical. Even if you're the one that's going to come back and read it, make sure you know why you made this abstraction. That's really important. And then the second thing, I think, is trying to make sure that you are not driving performance at the cost of simplicity, right? If I look at this and it's like, well, technically the fastest way is, creating this one-shot channel that watches, and once that gets something, it kicks off a receiving loop on a receiver, and then it does this lookup. If you can do that with a vec find or whatever, just do it. Unless you really, really need to eke out that performance, keep things simple where you can. You'll get to places like 1Password where it's like, yeah, we have to do all this zeroizing allocation, and we can't log dynamic strings. There's a whole loggable trait and this whole process it has to go through to make it, work. But that's not, you don't need to understand the internals of that every time, right? Just understand what you have to. Keep things simple wherever you can. Even here, we try to make sure that we're holding each other accountable for it doesn't need to be that hard. Keep it simple. Yes, it's technically faster this other way. We don't have realistic data sets that need that speed up. When we get there, we'll do that. Yes, in the future, we might have those and we might see a slowdown. And guess what? When that happens, we'll fix it and so forth. So I think a lot of it just comes back to Rust is complex. Keep it simple wherever you can. Learn everything that you come across, but take it one thing at a time. You will eventually get there. And that pattern is true all the way up into 1Password, where things are complex. Is keep it simple where you can, and then learn things one at a time when they can't be simple.
I can totally get behind that. It makes a lot of sense. It matches with what I see out there. Totally.
Yeah.
We're getting close to the end. And traditionally, the final question is, what's your statement to the Rust community?
Yeah. So, I mean, I think one of the, there is some amount of like thank you to the Rust community for keeping things open, right? Like I said, there's so many books out there, and the Rust book and the brown version of the Rust book is amazing with the quizzes and things. That's all great. I think we also need to continue to or increase how often we relate to people, right? Meet people where they're coming from, understanding, what they do and don't know. Obviously, with someone coming from my background, that was really critical that people here did that, and there's a lot of, acronyms or computer science knowledge, and there's so many people in Rust that are so smart. It can be difficult, sometimes coming in and going, they're like, well, you should make it a B tree set. It's like, why? What? I don't understand why that matters, and so forth. And just a lot of little things, right? Understanding, how did you learn what you learned? And it's like, oh, well, in my OS class, we did this. It's like, oh, I didn't have this, So there's a lot of that I think we can continue to improve on, just finding paths to not just go from zero to Rust, which I think we've started on, or we have a really good path to with the Rust book, or to go from Haskell to Rust or C++ to Rust or whatever, right? I think there is a missing middle gap of how do you go from TypeScript to Rust or this or that, where it's like, I understand variables, I understand all that. So the whole beginning of the Rust book feels boring and I'm getting lost. And then we go straight into memory or, async and really how async works. And there are these missing pieces sometimes. And so I think finding practical applications of Rust is really critical. One of the big things I push for a lot within 1Password and the Rust study group is, how can we build one cohesive thing? So it's not learning all the Rust concepts one by one, and it's not getting straight into the 1Password code base, which is terrifying. It is, how do I learn these concepts and apply them to one thing that I have now built? And now I understand why, a Tokyo mutex and a standard mutex, they're different, and why it matters that they're different. And you might need both in different cases, right? I've seen it in use, and now I can understand, thread boundaries or whatever it might be, or weight boundaries, I should say. And stuff starts to make sense to you because you've had a real use case for it, not just what it was when I learned it, right? There's things like Rustlings, which is incredible for like exercise-based learning. But at the end, I didn't see exercise 6 mesh with exercise 10, and now I understand that those are two maybe related things. And so, a lot of people say, right, build stuff. That is the greatest way, but that's not realistic for everyone. I was working before I became a developer. I was working, 50, 60 hours a week, and then, coming home and trying to keep, my apartment clean and all these things. And I did not have that much time left to just build things. It took me a year or more just to try and figure out, React or whatever it was at the time. And if it were Rust I was trying to learn, I have no idea how long it would have taken, and so I think just finding ways to bridge those gaps and make cohesive learnings that make concepts actually make sense holistically. I think that's a really, really huge area that will help a lot of people close the gap of Rust, which will help Rust adoption. I've seen that even here where it's like, we may have something we build in Go because ramping that team up on Rust is just not feasible in the time frame we have. Well, if there's better resources to get from Go to Rust, that becomes a non-issue, and I think we'll see Rust grow the more we are open to bringing people in from more intermediate spaces into Rust.
What an amazing and insightful answer. I can really get behind it. I can fully relate to that. Andrew, thanks so much for being on the podcast today.
Yeah, thank you very much for having me. I really, really enjoyed it.
Rust in Production is a podcast by Corrode. It is hosted by me, Matthias Endler, and produced by Simon Brüggen. For show notes, transcripts, and to learn more about how we can help your company make the most of Rust, visit corrode.dev. Thanks for listening to Rust in Production.